Before the holidays, we had learned how to deal with number theory, and we had just finished learning how to find the greatest common factor and least common multiple. We were this close to wrapping up and being able to take a test on this material. Excuse me. But we were just a day or two short. So we're going to start this 9 weeks by going back over what we were learning at the end of last 9 weeks, and then hopefully can quickly take a test on this and move forward. Again, before the holidays, we learned how to find the greatest common factor and the least common multiple. And that's easy to do if you know three things. The first thing you need to know is how to get a prime factorization. And another name for a prime factorization is a factor tree. The second thing you need to know is how to place the prime factorizations correctly on a chart. And the third thing you need to know is how to get the greatest common factor and the least common multiple off of the chart. So, if I gave you a problem like this, say 56, 84, and 112, and I asked for the greatest common factor and the least common multiple, the first thing I have to do is the factor trees. And again, the factor trees are easy if you know your times tables and if you know your divisibility rules. 56 should be very easy because it's in your times table. It's 8 times 7. Again, 8 can be broken down into 2 times 4, and 7 is already prime. And then 4 can be broken down into 2 times 2, and 7 is already prime. Now I have all prime numbers, so my prime factorization is 2 times 2 times 2 times 7. And notice I put them in order from smallest to largest. Now, 84 is a little more difficult. It's actually part of one of your times tables, but it's a times table that a lot of people don't know because it's 7 times 12. Now, if you know that it's 7 times 12, then you start with 7 times 12. If not, you use your divisibility rules to figure it out. And again, 84 is an even number, so 2 goes, and if you divide 2 in, it pairs with 42. So you could use 2 and 42. But that's not the best thing to use. It's most probably the worst thing to use. People constantly deal with trying to find starting with 2, and that takes more time. Because if you look at it, you would also know 3 goes, because the sum of the digits of 8 and 4 is 12, and 3 goes into 12. However, if 2 and 3 both go, that means 6 goes. So you could divide 6 in, and it'd be 6 and 14. By the way, 4 also goes because 4 goes into 8 2 times evenly and 4 goes into 4 1 time evenly. So if you divide it, it would go into the last 2 digits, the only 2 digits. But I think 6 and 14 works out real nice. And again, how did I know 6 paired with 14? You divide 6 into 84 and find out. When in doubt, work it out. 6 goes into 8 once, remainder 2. And then 6 goes into 24 4 times, remainder 0. So now this can be broken down into 2 times 3, and this can be broken down into 2 times 7. And now you have all prime numbers. By the way, use the commutative property multiplication to put them in order from smallest to largest. So instead of 2 times 3 times 2 times 7, make it 2 times 2 times 3 times 7. And the reason I think it's a good idea to put them in order from smallest to largest is so that you can easily put them on the chart afterwards, because you'll know all the smaller prime numbers in the front and you go to the larger prime numbers in the back. Now 112 is the hardest one of this because this is not in any of your times table. And again, you use your divisibility rules. It's even numbers, so you could use 2, but if you know your rules, you would know that 4 also goes because the last 2 digits are 12. And 4 goes into 12 evenly. By the way, I did show you a rule for 7 also, and 7 actually does go, because if I was to double the last digit, which is 2, if I double that, that's 4, and if I subtract that from the rest of the number, 11 minus 4 is 7, and 7 goes into 7. So most probably the biggest is the best, so 7 would be the best thing to use. But to be honest with you, most of you don't use that divisibility rule for 7. So for most of you, you'd most probably use 2 and 56. But I think it would be better to use 4. because the bigger the better. 7 is the biggest, so it's the best. But 4 would be better than 2. If I divide 4 into 112, it goes 2 times remainder 3, and it goes 8 times remainder 0. So I can break this up into 4 times 28. That can be broken up into 2 times 2 for 4, and 4 times 7 for 28. 2 is prime, 2 is prime, 4 is 2 times 2, and 7 is prime. Already in order from smallest to largest, I have 4 2's and a 7. And again, defining the right factor trees, the right prime factorization is the most important thing you have to do to get the right greatest common factor and least common multiple. If you don't get the right factor trees, you won't get the right answer. So you have to be very careful with this. By the way, when you finish doing your factor trees, if you want to check and make sure they're right, first of all, make sure all these numbers are prime. And then second of all, multiply them times each other and make sure they equal the 56. Are all these prime? If they are, multiply them times each other, make sure they're 84. Are all these prime? If they are, multiply them times each other and make sure it equals 112. These are the correct prime factorizations, so now we're ready to put them on a chart. And again, my chart looks like this. And the rule of the chart, and this is very important, is you take the first prime factorization and you put it across the first line, one in each row. And then you take the second prime factorization, put it in the second line, one in each row. But the catch is, you can only, if you put something here, you can only put that number here. So I start with the top row with a 2, a 2, a 2, and a 7. When I go to do my next chart, I can put a 2 under my 2, I can put the second 2 under the second 2, but I don't have a 3. So I have to start a new row for the 3, because only 2's can go under 2's and only 7's can go under 7's. I do have a 7, so I can put the 7 right here. So I go to the last one here, and it goes on the last line, a 2 under the 2, a 2 under the second 2, and a 2 under the third 2. But I don't have a place for the fourth 2, so I have to start a new row. And then I can put the 7 under the 7. Now, if I have the right factor trees and I have the right chart, it becomes extremely easy to get the greatest common factor and least common multiple off the chart. To get the greatest common factor, I multiply the rows that are completely filled. I have all 2's in this row, so that's completely filled. I have all 2's in this row, so that's completely filled. I don't have all 2's in this one because that was blank, but I have all 7's in this row, so that's completely filled. The 3 and the 2 only have 1 in each row, so they're not filled. So now 2 times 2 is 4 times 7 is 28. And my greatest common factor is 28. Now, my least common multiple, I multiply all the rows, the ones that are filled and the ones that aren't filled. Not all the numbers in all the rows, just all the rows. So I multiply a 2, a row of 2's, a row of 2's, a row of 7's, a row of 3, and a row of 2. And again, 2 times 2 times 2 times 7 is 56. And you go, how did you know that without multiplying? You're a genius. No, that's the prime factorization of 56. All right, so I can always take this out of the front. Now, 3 times 2 is 6. So if I want my least common multiple, I got to multiply 56 times 6. That's 36, carry your 3. 30 plus 3 is 33, and you get 336. So the greatest common factor, the largest number that goes into all of these numbers evenly, is 28. And the least common multiple, the smallest number that these numbers go into evenly, is 336. And you can't do that very easily just by looking at them. But if you get the right factor trees and you put them on the chart correctly, it's pretty easy to do. But the key is the right prime factorization.